Welcome back to another video again. So today we're going to be talking about two subjects again. I'm going to be covering grammar and I'm going to be covering biology. So today in grammar we're going to discuss relative pronouns and some subject and object pronouns. So a relative pronoun deals with the words who, whom, whose, that, and which. So an example of a sentence with a whoa, the sun is so weird. Okay, I think I fixed it, kinda. Whoa, okay, there we go. But an example of a word that has a relative pronoun in it would be the man who sold the world. In this case, your relative pronoun would be the word who. If you're going to, you can also use, so there's also a big case too with the words who and whom. So if you wanted to use the word whom in this case, you would be whom was the man that sold the world, or whom was the man who sold the world. Who is the doer or the person, while whom is normally like an object. So if you're talking about a dog, you can say the dog who I loved. You love that dog, the doer or person or thing. Or the girl who I loved, or in that case it's the doer or the person. And another one you could talk about is if you're going to use whom, you would be the dog whom I loved. So you're talking about at one point you loved this dog, and you're using whom in this case to describe like an object because it's whom. And another one you could say is the dog who loved me. So in this case, the dog did love you at one point, and the dog is still a person or doer. Like I said, we'll cover subject and object pronouns. So a subject pronoun does a thing, and an object has stuff or love to it. So, if you want to, I'll give you a sentence. So Mike wrote an email. In this case, Mike would be your subject and email would be your object, because Mike is a person, place, or a thing, while your email is just something you are. It's something that Mike is doing. He's writing an email. Now we're going to talk about, flip over real quick, hold on, and we'll talk about biology. So today we're going to be covering water, and we're going to be covering a little bit of the pH scale. So water, like I said last time, water is extremely important in our lives. Hold on, I'm trying to fix this and get it all set up. Water is extremely important in our lives. I'm just going to hold it. Water is a solvent. Water is a solvent, which means that it's easy for something to dissolve in water. So, if you think about it, NaCl, or sodium chloride, which we better know as table salt, the sodium has a positive charge, while the chloride has a negative charge in that ion. If you think about it, water, when you put sodium chloride or table salt into water, it dissolves really easy. And, the reasoning behind that is, so you have the negative ends of the sodium chloride ion are attracted to the water, even though you may think that the sodium chloride itself, the sodium ion itself is a positively charged ion. It still has negative ends, and those negative ends are attracted to the water in a cohesive bond because it's two molecules attracted to each other. Partially charged oxygen atoms will bond to the sodium ion, while hydrogen ions bond to the oxygen ion. So what you'll see is a sodium ion, and on that sodium ion there will be 5 oxygen ions bonded to that sodium ion, and then you will see 2 hydrogen ions bonded to each one of those oxygen atoms. So in that case, you would have 5 water molecules bonded to one sodium ion. And now we'll talk about like the chloride side, so the Cl part. With the chloride ion, you have 2 partially charged hydrogen ions bonded to the chloride, and the oxygen ions will bond to the hydrogen ions. So in this case, instead of having your oxygen ions bonded to your sodium, you would have your hydrogen ions uh, bonded to your chloride ions first, because it is because it's already partially charged. So you have your hydrogen ions first, and then you have your oxygen ions bonded to your hydrogen ions. So if that makes a little bit of an essence and a scale, I'll say like a little recap real quick. So in water is a solvent, which means that it is easy for something to dissolve in water. And NaCl, or table salt, dissolves in water very easy. And the sodium in the NaCl compound ion is positively charged, but it does have negative ends. And the chloride is negatively charged, but it does have positive ends on it. So, when you dissolve sodium chloride into water, the positive end, or the partially charged oxygen atoms will bond to the sodium, while the hydrogen ions bond to the oxygen ions. So it'll look kinda like this. Hold on, I'll draw it for you. So you got your little circle, and that's your sodium. So you have your N. Hold on, give me a second. Na, and then you have your little plus because it's positively charged. I think that it's positively charged, and then you have your oxygen ions. So you have one. Oh. Hold on a second. Almost done. Okay. Now, that is what it'll look like when you dissolve table salt into water. So you have your sodium ion right here, and then bonded to your sodium ion are 5 oxygen ions, and bonded to your oxygen ions are 2 hydrogen ions for each oxygen ion. And in essence, whenever you do chloride, so I'll do chloride real quick. Cl, negative, because it's negatively charged. So in this case, you have shoot. Okay, that's what it looks like there. If you can't really tell, now it's kind of the opposite thing. So your chloride ion is negatively charged, and bonded to your chloride item, you have 5. You have in count you have 10 hydrogen ions, but 2 ions for each oxygen ion. You have 5 sets of 2, so 1, 2, 3, 4, 5. And bonded to each one of your set of 2 is 1 oxygen ion. See, 1, 2, 3, 4, 5. But in essence, that is pretty much, that is water on a scale. There's water in an essence, but we'll cover more on that. That's actually pretty much all of what we're going to cover on water. Next time we'll talk about the pH scale and acids. Thank you so much for watching. God bless, and I will talk to you guys next time. See ya.